Hello guys, and welcome to the second part on solving this problem. So previously I showed you how you can do this using this inequality which we engineer. So now let's engineer the inequalities which we can try. Okay, so this will be a bit different. So let's try x, y, then y, z, z. Okay, so that's usually how the way I remember it. So and just put negative signs in front between the variables. Of course, this should hold true. All right. So the other thing is you should just observe the sign which is in front of the inequality sign. If there is an equal sign, make sure that your inequalities they also have an equal to sign. All right. So then the approach is almost the same as the one which we did here, where we had to add all the terms on the left hand side and on the right hand side. So this one is pretty straightforward. We are going to add the difference of x minus y squared and the difference of x minus z squared and the difference of y minus z squared for everything greater than 0. So then we just have to do an expansion. So I'll just do a quick expansion. So we get a squared then minus 2xy then a plus y squared. We are done with this first part. Okay, so let's do another one for it's an x squared then minus 2 xz then plus z squared. Okay, then let's move on to the last one. We get a y squared minus 2 yz plus a z squared is greater than or equal to 0. All right, so now it's just a matter of collecting like terms. Okay, I think you know like terms which you have the it's the same like which share something in common, like here x squared and x squared is share something in common. Okay, so we have an x squared and an x squared here. Let me use a different pen. We have an x squared here and an x squared here. Okay, so if we add them together, we end up with an 2x squared, right? And we also have a y and a y here, and also we have a z and a z squared here. Okay, so we're gonna have a plus 2 y squared plus a 2 z squared. Okay, so then we move on to the products of these variables, which we can start with this one minus 2xy and then minus 2xz, and then move on to this last time and then we put that sign. So minus 2xy then minus 2xz then minus 2yz greater than or equal to 0. Okay, so then because this inequality expression is actually our guideline. Okay, so we always need to come back here and verify if we are going through if we are still in the path. So we need to make sure that all the products of the variables are on the same side, and also the coefficients of the products of the variables are just 1. So we're gonna factorize the common expression, and if we move the rest of the terms to the other side, of course we're going to have a 2. Let me just do a quick factorization as well. Then we have an xz, an xz, then minus a plus yz. All right, then of course, as you already observed, if you watch the previous video, these two are going to cancel out, so we're going to end up with x squared plus y squared plus z squared, right? Is greater than or equal to xy plus xz then plus yz. And finally, we have managed to show that the product, the summation of the square of the variable x, y, z is greater than or equal to their product.